G's, and if there's no gravity, there's no top, there's no bottom, you feel 3 G's all the time. In fact, there's no such thing as a vertical circle without gravity, correct? Yes? Okay. Now, if we impose gravity on this thing, we've got 3 G's of force that we feel toward the outside, yes? We always feel flung to the outside. Gravity provides how many G's? 1 G down, yes? Okay, what do we feel? 2 G's, yeah, there we go. Okay, so if it's 3 G's, there's 1 G, we feel 2 G's. Okay? That's what we feel, right? And then at the bottom, we feel we've got that 3 G's, right? And then we've also got gravity, which is 1 G, but they're in the same direction, yeah? Okay, so we're going to feel, what are we going to feel? 4 G's, that's fun, isn't it? Okay. Yeah, so at the bottom we're going to feel 3 plus 1. Yeah? And of course what's really fun is if it's pulling about a G, then you go from feeling like 0 G's at the top to 2 G's at the bottom and 0 G's at the top. Yes, sir?
Is there like a limit on how many G's you can experience on a roller coaster?
How many G's? Yeah, the question is there a limit to G's? Not for design, but for like humans surviving it, yeah, right? And I think politely they try to keep it at like, I think it's like 3 to 5 G's or something like that. But what they can do, they've discovered, is that they keep your heart and your torso sort of fairly calm. They can make your arms and legs fling around, and it's much more thrilling, right? And so they've got these rides, like these ones that you ride in, like they look like a crazy chairlift, right? That you ride in, you're sort of suspended in them, and you swing out and do crazy things, but your heart and lungs and stuff sort of follow more of a subdued path. So there we go. Okay, so let's look at a problem that we can do. This is an example of a problem we can do, and it says a rider moving in a 3.75 meter radius circle. Okay, so here's our circle. See if I can do that. Yeah. Oh, that wasn't such a good circle, but it was pretty good. Okay. Okay. 3.75 meter radius circle feels 1.2 at the top. At the top. There we go. So okay, what is the ride really doing? If you feel 1.2 at the top, the ride is really doing 2.2, right? Okay. So the acceleration of the ride is 2.2 G's, right? So that's 1.2 G's plus 1 is 2.2 G's, right? Okay. So that's the first question, is how many G's is the ride pulling? It's pulling 2.2 G's. That's what it's really doing, right? How many do they feel at the bottom, though? 3.2. 3.2. They feel 1 more than what the ride does, right? Okay. Or in general, 2 more than you feel at the top, right? Always, right? So at the bottom, they're going to feel 3.2 G's. By the way, what you feel is what you can actually use that to calculate force. So that's the pirate way. I'll show you that later. Okay. And then let's see, what is their tangential velocity? So how fast is the ride spinning? What are we going to use? Are we going to use what they feel at the top or bottom, or what the ride is really doing to calculate that? What it's really doing, okay? So the first thing is to turn G's into meters per second squared, right? 9.81. All right, so 2.2 times 9.81, 21.582. Okay, and then I'm going to use, I guess we want to know the velocity, so I'm going to use that formula. So 21.582 meters per second squared equals v squared divided by 3.75, right? So that, again, it's like, I guess we're solving, it's a pirate equation, square root of AR times 3.75, and I'm going to square root that. 8.996. Yeah. We have 2 sig figs. How do you round that to 2 sig figs? You have to say 9.0, don't you? Yeah. Yay. Look how fast you're learning. Let's have you guys try these. So these are the first set of whiteboards.